Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL May 2021 paper 2 time zone 1 past paper questions, and today we will be solving question number 7. We are solving one question each day. You will be getting the solutions to all the previous questions in the description area. You will be getting the links to those questions and in the playlist. Okay, so without any further delay, let us start with our today's session. Question number 7. It contains 7 marks and it says a continuous random variable x. X is a continuous random variable and it has the probability density function f given by f of x equal to x over square root of x squared plus k whole to the power of 3 for x between 0 to 4 both included, and f of x equal to 0 otherwise for other values of x f of x equal to 0. So where k belongs to the set of positive real numbers, and they are saying, now coming to subpart A, they are saying show that square root of 16 plus k minus square root of k equal to square root of k times square root of 16 plus k. From where is the 16 coming? No idea. K is over here, but where is the 16 coming from? Do not know. But well, what we know is, since this is the probability density function, the area under the curve, the total area under the curve, because the total probability is 1, so the total area under the curve will be equal to 1. So if we integrate the whole area taken as the two limits, the value of that integration, the result of that integration should be equal to 1. But we don't have to take the whole area because we are having a function expression given only between 0 to 4. For other values of x, it is just equal to 0. So we don't have to take the entire area. We have to just integrate between 0 to 4. This is what we can understand, because we have no clue as to from where is the number 16 coming. No idea. So let us check. Let us do not leave a question. It is containing 5 marks. Of course, you will not be leaving a question. You will be trying. So how can you try? You know it is a probability density function. So let us integrate. And since it is having a function expression only for x values between 0 and 4, both included, we will be taking the limits between 0 to 4. Okay? Fine. So therefore, we start with the part A. It will be, limits will be from 0 to 4, x over square root of x square plus k whole raised to the power of 3 dx. This should be equal to 1. Okay? Fine. Now we have to basically integrate this. How to integrate? We have to substitute. So let t be equal to x square plus k. Okay? So dt by dx will be equal to 2x. Okay? Or dt will be equal to 2x dx. But I'm seeing in the numerator, I'm having only x dx. I'm not having 2x dx. So let us get the expression for x dx. X dx will be dt over 2. Okay? You can write dx as dt over 2x, and the x in the numerator and x in the denominator, they will be cancelling each other. Or I keep it, whenever I see there is x in the numerator, I keep it as x ds. So, but over here I'm getting the result of differentiation is 2x dx, not x dx. So I'm just taking 2 in the as the denominator. Dt by 2 is x dx. Okay. Now coming to the limit, when we substitute, the limits will not remain the same. A is a positive real number, they have said. It is not equal to 0. That is. So when x equal to 0, 0 square is equal to 0 plus k. We do not know the value of k. So the lower limit when x equal to 0 will be equal to k. And when x equal to 4, it will be 4 square is 16 and 16 plus k. So the limits of integration will be changing from 0 to 4 to k to 16 plus k. But I don't have to I don't want to change the limits. Let them stay as it is. Right now, I am focused on the integration. So I am not taking the definite integration. Rather, I am taking the indefinite integration, that is without the limits. Okay. Let me first of all integrate. So this will be, in place of x dx, I'll be writing dt over 2. But before that, x squared plus k can be written as t. So it is square root of t cubed. Okay. And in place of x dx, I'll be writing this as dt over 2. Okay. So I'm just doing the integration. I'm not even taking the equal to 1. I'm just doing the integration. So this is equal to, I can take the half outside, and this is actually 3 over 2. Square root of t cube is 3 t to the power of 3 over 2, and it is in the denominator, so I can bring it up, and the power will be t to the power of negative 3 over 2 et. So this is equal to half, and t to the power of negative 3 over 2 when integrated gives what? It will be negative 3 over 2 plus 1 over negative 3 over 2 plus 1. Okay. And of course, there will be the plus c because I haven't taken the limits. So this is equal to half, and this is negative 3 over 2 is negative 1.5. Negative 1.5 plus half plus 1 is negative half. Okay. So fine. So it will be t to the power of negative 1.5 plus 1 is negative half. So it will be t to the power of negative half over negative half. So this when comes up, this is half divided by half. Okay, half is in the numerator and this half is in the denominator. So half divided by half will be 1. And the minus sign will be coming out. So this is in fact equal to minus t to the power of minus half plus c. Okay. And what was t equal to? Now we will be putting back the expression x squared plus k. So now I put back the expression minus x squared plus k to the power of negative half. And since I am putting back the expression, now I am taking the limits. Therefore, I am not writing the C anymore. This should be equal to 1. Okay. So now let us see what happens. It is minus, when x equal to 4, it is 16. 4 squared is 16. Plus k to the power of negative half, and minus of minus, x is 0, so it is 0 squared is 0, plus k to the power of negative half is equal to 1. Okay. And since the expression is containing square roots, so instead of negative half, let me write this in this form. Negative 1 over square root of, now you see the 16 has come. So we may be a little more energized seeing the 16, because previously when we had started, we had no idea whether we are on the right track or we are doing something useless. Because we didn't know from where will we be getting the 16, number 16. But now we are at least seeing the number 16, and we are seeing the square root of 16 plus k. This part has come. Okay. And minus of minus is plus, so it is plus 1 over e to the power of negative half, so it is root k. Should be equal to 1. Okay. So I can take the common denominator as root k times root 16 plus k, and it will be, let me write this root 16 plus k first of all, because this is having a minus sign. So root 16 plus k minus root k is equal to 1. And then we are having, let us cross multiply. So we are having root 16 plus k minus root k. This is equal to root k times root 16 plus k. Is this the expression that has been given to us? Yes. Root 16 plus k minus root k equal to root k times root 16 plus k. We have got this expression. Okay. So we have shown this. Okay. Fine. We have completed subpart A. Coming to the subpart B, find the value of k. We have already got 5 marks. Find the value of k. It is a paper 2 question, so we will be using the calculator. Okay. Subpart B. We go to menu, algebra and numerical solve. It is root 16 plus k. Okay. Root 16 plus k minus root k minus root k let me bring this also to this left hand side, minus root k minus root k times root 16 plus k equal to 0. Comma, we have to declare the variable, it is k. Okay, fine. K is 0.645 up to 3 significant figures. So using in solve or using GDC, if I write the solve, K is equal to 0.645. 0.645 up to 3 significant figures. Okay, K was a positive real number. Yes, K is a positive real number, so we have got a positive real number, and we have completed solving this question number 7 totally. The part A and the part B. So, students, thank you for staying with me till the end, and we meet again tomorrow. We'll be solving question number 8 tomorrow of this paper, and if you have any doubts, please feel free to write to me in the comment section, comment area, and I'll be conducting group online math tutoring sessions for IB Math A, SL and HL students starting from July. From the month of July, you are seeing my email ID, you are seeing my WhatsApp number. If you are interested in joining my classes, please do contact me. You may mail me, you may text me. And so that was all for today, and bye for now.